guys, this is Sanjay from FTC team 7477 Super 7. Today I'm going to be explaining and showing you how to code the insertion sorting algorithm in Java. Insertion sort is one of the simplest sorting algorithms often used for small data sets. So in this video, we'll talk about how insertion sort works with examples of code line by line. So let's get started with the actual insertion sort method, right? So let me just code that. Sorry. Alright, first let's look at how you define the method, right? So similar to other sorting algorithms such as quicksort or bubble sort, it declares public static void, which means that any element in here can be used throughout the whole class, and it doesn't return any value because of the void here. It takes in one parameter, which is int array, which is the array that we're going to sort. So let me just finish coding this. Alright, so this is the insertion sort method. It sorts an array in ascending order by iterating through the array, picking one element at a time, and inserting it into its correct position, which is why it's called insertion sort. The algorithm mimics the way you might shuffle playing just cards in your hand. You take one card at a time and place it in the right spot dependent on the other cards. So you could think about it that way. First, let's talk about the outer for loop. For int I equals 1, I is less than array.length, and I increments by 1 each iteration. So the sorting begins with the outer loop, which starts at index 1 and runs till the end of the array. This loop divides the array into two parts, a sorted section at the beginning and an unsorted section that will process step by step. At each iteration, the current element, array of I, is the one we want to insert into the sorted section. Next, let's talk about this line, int key equals array of I. So the variable key, it stores the value of the current element we're working with. This is the element that we'll be moving into its correct position within the sorted section of the array. Next, let's talk about this while loop. Next, let's talk about this while loop. While j is greater than or equal to 0, and array of j is greater than or equal to key, array of j plus 1 equals array of j equals j minus 1. Right? So what this line does, this is where the insertion actually happens, this inner while loop. This inner while loop, right? This is where the insertion actually happens. We compare the key with each element in the sorted section, which is what this part does, and we move from right to left. If an element in the sorted section is larger than the key, we shift it one position to the right, which is essentially what this says. J plus 1 is one position to the right. This process continues until we find the correct position for the key. The condition j is greater than or equal to 0 and array of j is greater than key ensures that we don't go out of bounds and that we only move elements larger than the key. Once we found the correct position for the key, we insert it into the sorted section by assigning it to array of j plus 1, which is essentially what this line does. Array of j plus 1 equals key. At this point, the sorted section has grown by one element, and the next iteration of the outer loop will process the next unsorted element. So the outer loop does this for every single element in the array until the array is finished, which shows why it isn't that efficient, because you could compare it to linear search against binary search. Linear search processes it one by one, like this. It goes for each single element in the array, but binary search, it actually either cuts the size in half or it finds it. So yeah, it's pretty efficient. So now let's move on to the main method where we declare our array and where we call insertion sort. So let's make our array. Let's make it 5, 7. Okay, this is in order. Wait. Alright, so just a random array with some random integers, right? So now we call insertion sort of array. Right? And now we can individually print out each element in the array by using this for loop. Which it increments through each element in the array and it prints it out. So we use IntelliJ's built-in shortcut for system.out.println, sout enter. And now we can print array of k. Actually, no, sorry, we aren't using k here. So let's run this. And our array is sorted. But did you notice how long it took for that? Like, let's just run it again. It took a long time for it to run, which shows how it isn't really efficient for bigger data sets. Compared to quicksort or merge sort or heap sort, they do it in a significantly lesser time than this. So let me give you guys an example of how insertion sort works. So let's start with the first element in the array. So it's already sorted because a single element is already sorted, right? So let's take the second element and compare it to the first. If it's smaller, we move it to the left. If not, we move it to the right. So then we repeat this for every single subsequent element, where we shift larger elements to the right and we shift smaller elements to the left if needed. This continues until every element has been inserted into its correct position. So now let's do a quick recap of insertion sort. Insertion sort is a simple but effective sorting algorithm for small data sets. Its time complexity is O of n squared in the worst case. Let me just type this, O of n squared, worst case. So its time complexity is O of n squared in the worst case, but for nearly sorted arrays, it can be quite efficient. Thanks for watching the Super 7 programming tutorial in Java, and make sure to be updated for more new programming tutorials made by Super 7.